The birth of the solar system and the Earth. Everything begins with the end. For something to be born, something has to die. The history of the Sun begins with the explosion of death, a supernova. 13.8 billion years ago, the universe was born. Almost 9 billion years passed until a cataclysm occurred in one of the arms of our galaxy, the Milky Way. A giant star reached the end of its life and exploded in a supernova. This explosion scattered heavy elements in space: iron, oxygen, and silicon, all of which were created in the cores of old stars. These elements would become the building blocks of our solar system. Thus, death became the beginning. The birth of the Sun, a cloud that shone. The material from the supernova explosion began to interact with a cold gas and dust cloud, the solar nebula. Gravity began to compress it. The further it went, the more particles gathered together. In the center of this cloud, a protostar is formed. The temperature is rising. The pressure increases. And then the thermonuclear reaction starts. The protostar becomes a real luminary. Our Sun appears. At first, it was volatile, aggressive, and ejected plasma streams. But it was its light that began to disperse the remnants of the cloud and free up space for the formation of planets. Planet formation. A flat protoplanetary disk cloud remained around the young Sun. It consisted of dust, ice, gas, and debris. They began to stick together under the influence of gravity. This is how planetesimals appeared, objects ranging in size from kilometers to hundreds of kilometers. These bodies collided, merged, collapsed, and reassembled. It was a chaotic cosmic dance. And in this chaos, planets were born. Giants like Jupiter and Saturn captured most of the gas. And closer to the Sun, where it was hotter, rocky planets formed: Mercury, Venus, Mars, and Earth. The solar system, a complex ecosystem in space. When we think of the solar system, we often imagine it as a simple set of planets orbiting the Sun peacefully. But in reality, it is a highly complex, dynamic ecosystem. Jupiter, for example, acts as a gravitational shield. It attracts most comets and asteroids that could crash into the Earth. Without it, the history of life might not have begun. And Uranus and Neptune. They probably weren't always in their places. Modern models suggest that the planets migrated. That is, changed their orbits after formation. Perhaps that is why some of the objects from the Kuiper belt were ejected outward, and some were ejected into the system, carrying organic matter and water to the young planets. The Earth, scorched, destroyed, and yet alive, the young Earth was a hot ball of magma. Its surface was boiling, and volcanic eruptions never stopped. And that's not all. A Mars-sized object called Theia collided with it. As a result of this cataclysm, part of the Earth's matter was ejected into orbit, and the Moon was formed from it. The Moon is no accident. Without it, there might not have been stable seasons, tides, and life. And then there was the reign of asteroids. They are called late heavy bombardment. They brought water, molecules that stayed on the surface and laid the foundation for the oceans. After the Great Collision with Theia, the Earth underwent a complete transformation. A core was formed in its interior, around which a mantle layer was formed, and then the crust. This separation into layers is the key to the formation of the magnetic field, Without it, the Earth would be constantly bombarded by solar wind particles, as happened with Mars. But our planet has protected its atmosphere. And perhaps this is the reason why water remained on the surface and did not evaporate into space. An interesting fact: the iron that flows in our blood is the remnants of a molten core that did not get to the center. The calm after the storm, the first oceans, the first atmosphere. Over time, the Earth's surface cooled. The first clouds were formed from water vapor released from the interior. It rained for thousands of years. The oceans filled up, and the atmosphere became denser. There was no oxygen in it, only methane, ammonia, and carbon dioxide. But it was the perfect environment for the first chemical reactions that led to the emergence of life. The atmosphere that breathes. For the first million years, the atmosphere was hostile to us. Methane, ammonia, hydrogen, water vapor. But there was no oxygen. It was a reducing atmosphere, favorable for chemistry, but dangerous for modern life forms. However, it was in this atmosphere that the conditions for abiogenesis, the chemical origin of life, arose. Miller-Jouret's 1953 experiment showed that by simulating such an atmosphere, amino acids, the basis of proteins, can be formed. That is, the laboratory managed to repeat the first steps of nature. The incredible story is ours. Look around you. Trees, oceans, cities, people. All of them started as dust. Dust from a star that died billions of years ago. Every atom in your body was once part of a star. The story of the sun is not just the story of light. It is the personal story of each of us. We are the result of stardust. Our sun is a descendant of a supernova. The Earth has gone through fire, shocks, storms, and all this has become the basis for life. This is the end of this video, but the next topic is the origin of life, the first microorganisms. Theories about the origin of life, RNA world, hydrothermal sources, first cells. There will be a lot of interesting and new things that you did not know yet. Be sure to subscribe and like the video, because this is the Road to Past channel. Here you will learn how our world was formed and what happened to it before we existed. See you soon!